Alrighty, this is the Chapter 2 test study guide. We're going to go through all the answers here. Please make sure that you either pay attention and write down, or if you just need this as a way to check your answers, you are doing that. We will go through it now. For number 1, what are the rules for multiplying and dividing all integers and rational numbers? Well, we've got 2 rules. If both of these share the same sign, so that would be positive and a positive, or a negative and a negative, my answer is positive. If the 2 numbers you're looking at have different signs, so our cases would be a negative positive or a positive negative, right? Those contrast, and our answer would be negative. All right, moving to number 2. I have a negative times of positive, right? That parenthesis there just means multiply. 5 times 9 or 9 times 5, if you do your nines trick with your hands and you put down that 5th finger, you should get an answer of 45. Right? Positive times negative would be a negative answer. It should be negative 45. Number 3, I have a negative times a negative. I know those have the same sign, so my answer has to be positive. 6 times 3 is 18. A negative divided by negative, same thing as multiplying, is going to result in a positive number. 50 divided by 10 looks like this. 10 does not go into 5, but it does go into 50 5 times, and it does so evenly. I should get a positive 5 for an answer. 15 over 3. Whenever we divide fractions, that numerator goes inside, denominator outside. I have a positive over a negative. Different signs mean this is going to be a negative answer. 3 doesn't go into 1, but it does go into 15 exactly 5 times. I should have negative 5 for an answer. Number 6, write the fractions as a decimal. For this case, we're going to divide. 4 goes into 1 0 times, but goes into 15 3 times. I do not have a remainder of 0, so I need to add a decimal point and add a 0 to the tens place. 4 goes into 37 times. 7 times 4 is 28. This would result in 2. Add a 0 to the hundredths place. 20 goes into 4 5 times, and it does so evenly. My decimal would be 3.75. Number 7, 2 1/3. There's a couple different ways we can do this. We can turn 2 1/3, a mixed number, into an improper fraction, or we can also just separate the whole number and the fraction. I prefer to separate them because then I'm just working with a smaller fraction. 1 would go inside, 3 goes outside. 3 does not go into 1, so I would add a decimal and a 0 to the tenths place. 3 goes into 10 3 times. I get a 9, and I'm left with 1. If I were to keep adding zeros, no matter how many times I tried it, I would keep getting this repeating pattern of 3s. So I can assume that that repeats forever. My decimal would be 0.3 repeating, and then I would just take my whole number and put it out front. Again, if you want to see that these actually match, 3 and 7. 3 goes into 7 twice, and there is our repeating pattern again. For number 8, write the decimals as fractions in simplest form. This one we need to make sure we remember which places these are. This is the ones place. This is the tenths place. This is the hundredths place. To determine what goes on the bottom, we look at the last digit in the decimal. It is in the hundredths place, so the bottom would be 100. What goes on top is anything after the decimal point, so that would be 12. I need this in simplest form. Both of these can be divided by 2. 6 and 50 also are both divisible by 2, and I get an answer of 3/25. Make sure you go back and check, was there a negative? If there was, my answer is negative 3/25. 5.4, again, the 4 is in the tenths place this time, so my fraction should be over 10. Anything after the decimal place goes on top. My whole number stays out front. I now have a mixed number. The only simplification needed here is to divide both of these by 2, and I get an answer of 5 2/5. There is no negative. That's my answer. All right, finding products and quotients of rational numbers. For this one, I've got a positive times a negative. Different signs means this answer is negative. 0.09. I like to put the number with the least amount of digits on the bottom. You don't have to. If you want to do it the other way, you can. 4 times 9 is 36. 4 times 0 is 0, plus 3 is 3. And I would get a 0. Add a placeholder 0 for the ones place. 3 times 9 is 27. 3 times 0 is 0, plus 2 is 2. 6, 7 plus 3 is 10. 2 plus 0 plus 1 is 3, and I get a 0. To determine where that decimal point goes, I look how many digits are after decimals. There's 3 of them, so I make sure my answer matches. Okay, we also said it was positive times a negative, and my answer should be negative, so negative 306 thousandths is my answer. For this one, we need to change our mixed number into an improper fraction. This would become negative 9/4, being multiplied by negative 8/9. Here we can do some canceling. 9 and 9 are both divisible by 9. They both become 1. Negative 1 times negative 8 is positive 8. 4 times 1 is 4. 8 divided by 4 is 2. To check, I had a negative times by a negative. I should have a positive answer. Negative 5/6 divided by 1/3. This is a case where we are dividing by a fraction, so we need to be multiplying by the reciprocal. Okay. We are now multiplying instead of dividing. The reciprocal of 1/3, we just take the numerator and the denominator and we flip them. Okay. We now get 3/1. Negative 5 times 3 is negative 15. 6 times 1 is 6. You could do this and then simplify. You also could have noticed that 3 and 6 can simplify to 2 and 1, because I divide by 3 in both cases. My simplified version of this would be negative 5/2, which written as a mixed number would look like this. Again, check. Negative divided by positive. Different signs mean this is a negative. For number 13, I've got a negative being divided by a negative. This has to be positive. To set this up, 12.56 goes inside, 0.4 goes outside. I get to move this decimal point to make that outside number a whole number. Whatever I do outside, I must do inside, exactly the same. My new division problem looks like this. And from there we divide. 4 does not go into 1. 4 goes into 12 evenly 3 times. Drop down the 5. 4 goes into 5 once. Drop down that 16. Make sure you line your decimal up. 4 goes into 16 4 times. My answer here is 31.4. Check to make sure my answer matches. 14, I've got a complex fraction here. Again, a complex fraction is when I've got fractions inside of fractions. First thing I need to do is take a look at any single equation happening within a fraction. In this case, I've got an addition statement. I like to separate it out, bring it up here. 2/5 plus 1. We know that 1 is also written as 1 over 1, right? It represents a whole number. I cannot add fractions that don't have the same denominator, so I need to make common denominators. This one is nice. I just have to multiply both by 5. I get 2/5 plus 5/5. Bottoms stay the same. I had 2 slices of pizza. I added 5 more. I now have 7. I'm going to substitute that back in for here since I know that that's equal. I get negative 1/5 over 7/5. And now I divide. Negative 1 over 5 divided by 7/5. Oop, I'm dividing by a fraction again. This is where I multiply by the reciprocal. The reciprocal of 7/5 is 5/7. I can do some cross simplifying here. Both of these are divisible by 5. Negative 1 times 1 is negative 1. 1 times 7 is 7. I had a negative over a positive. This has to be a negative answer, which my answer matches. For number 15, we need to remember our order of operations, which we oftenly refer to as PEMDAS, parentheses, exponents, multiply, divide, add, subtract. First step would be to look at parentheses. I do have parentheses here, but 15 is really talking about a negative number being squared, and this is, parentheses here is just saying, hey, these two numbers are multiplied. So really, there's nothing happening. In the parentheses, we are all good. Next thing to check is exponents. I do have an exponent here. That negative is inside of the parentheses, so I need to carry that through when I expanded it. Negative times negative should give me a positive answer. 1 times 1 is 1. 4 times 4 is 16. It needs to be positive because I just said negative times negative. I like to rewrite everything that I didn't use again. My exponents are all done. I need to start looking at multiplying. For this one, these two are being multiplied here. 3 times 1 is 3. 4 times 2 is 8. I'm going to bring down everything I didn't use. I cannot add fractions with different denominators. I need to make them common. To do that, I just multiply the second one by 2 on top and bottom. This becomes 1/16 plus 6/16. My bottom remains the same. 1 plus 6 is 7. Again, I go back and check my negatives. This is positive. This is positive. This is positive. I should have a positive answer. Okay. For number 16, consider the following pattern: 3072, and then 384, and then negative 48. When it says describe the pattern, it's looking for what is happening each time I go to a new number. Okay. Well, first thing we can notice is that every single time it's flipping between negative and positive. Right, negative 3072, positive 384. Negative 48, my next number's got to be positive. So there's that. The second step is to find out what's actually happening. How do I go from each number to the next? Well, to do that, all we have to do is say, okay, what is 384 divided into 3072? Now, I don't know about you, but I did not study my 384 multiples in school. So if you need to, take the time and figure out, which one would it work. Again, you can kind of guess and check. I'm going to guess 7. Okay. 7 would be 28. 8 times 7 is 56, plus 2 is 58. 7 times 3 is 21, plus 5 is 26. I think I can squeeze in one more. That would be 2. Or 12, that would be 7. That would be 0. And would you look at that? It does go in evenly. I tried 7, I needed one more, meaning this goes in 8 different times. So when I describe the pattern, we can say that each time I am dividing, right, it's going down, I'm dividing by 8, and in order to kind of get this negative, positive, negative, positive, negative 3072 divided by a positive 8 would give me a negative number. So really, this needs to be negative. All right, and we can say we are dividing by negative 8 each step. The next number in the pattern, well, we just divide by negative 8. We said that's what we were doing above. We do the same below. Take that last number, negative 48, divide it by negative 8. You should see you get a positive 6. Last page here. Two integers have, A and B have a product of 18. What are all the number pairs A and B could be? If we list them out, 1 and 18 would be a product, right? Product means the answer to a multiplication problem. 2 and 9 would multiply to 18, and 3 and 6. Remember our negative pairs, and negative times a negative is positive. So negative 1 and negative 18, negative 2 and negative 9, negative 3 and negative 6. These are all my pairs. You should have 6 of them. What is the least possible sum of A and B? Right? Least possible means most left on a number line. And sum means the answer to an addition problem. So I'm going to add all these together. Right? We already said that these are all of our number pairs. When I add these, this is 19, 11, 9, negative 19, negative 11, negative 9. The least possible would be the most left number on a number line, meaning the most negative, which so happens to be this one. My least possible sum is negative 19. For number 18, how do I find the range of the set of numbers? The range of a number set would be the largest value subtracted by the smallest value. Right, it's telling me how big a part is this data set. Number 19 asks, what is the range of these numbers? Okay, I could try and convert them to fractions, but then I would have to make common denominators, and that gets a little bit long, so I'm just going to convert them to decimals. 2 1/3, we could divide it, but hey, guess what? Look at problem number 7. We already did 2 1/3. If you wanted to, you could, but this is just going to be 2.3 repeating. 14/5, this would be looking like that. Numerator inside, denominator outside. 5 does not go into 1, but goes into 14 twice. I get a 4, I need to add a decimal and add a 0 to the 10th place, which I get an 8, goes in evenly. This is 2.8. I'll rewrite these really quick. 2.5, 2.3 repeating, 2.3, and 2.8. Clearly 2.8 is the biggest of all of them. I know that 2.5 is not the smallest, it's bigger than 2.3. Between these two, we need to kind of look at the hundredths place. The next number in 2.3 repeating would be a 3. Here it would be a 0. If I'm looking for the least or the smallest value, this one is smaller than 2.3 repeating. So I subtract it. This subtracted, make sure you keep your decimals in line, which would be a 3. 0.5 is my answer. Last two questions here. We have a problem that says a meteor can travel up to 500 miles per minute in the atmosphere. And it's asking how far could it travel if it was in 20 seconds. Okay, for this one, we kind of want to set it up a little bit like fractions, right? I know that for every 500 miles, it takes 1 minute. 500 miles per 1 minute. Next, it's asking about seconds, right? We kind of we can't really compare minutes to seconds until we know how many minutes are in seconds or seconds in a minute. That conversion is actually for every 1 minute, there's 60 seconds. Okay. And what this one's asking about is, okay, how about 20 seconds? Right, we're going to make this just look like a fraction. This is kind of our general setup because we actually get to cancel out our minutes, just like numbers would cancel out top and bottom, and seconds, and we're just left with miles, which is what we want because it's asking how far. Miles is a measurement of distance. From here, we can simplify our numbers a little bit. Each one of these numbers is divisible by 10, so we can get rid of the last 0 on them. 6 and 2 are both divisible by 2, so we also can do that. To kind of make everything look a little bit nicer, 500 miles over 1 over 3 and 1 over 1. I get 50 miles. 1 times 3 times 1 is 3. This simplified would look like this. 3 goes into 5 one time. 3 goes into 26 times. Right, add my decimal and a 0. And you're going to notice we keep repeating 6's. So, how many miles in 20 seconds? 16.6, and that 6 repeats miles. Lastly, I am trying to find the volume of a rectangular prism. The volume equation is right here, so I just got to match each part. 4.5 was the length. The width was 6.2. The height was 2. Multiplying these two together, you should get 12.4. Finally, when we multiply these two together, I get 20, which would be, that would be 12, and this would be 6. Drop a placeholder 0, 16, 9, and 4. Everything added up would get us here. We have to match the number of decimal places. There are 2. Make sure there's 2. We get a volume of 55.8 inches cubed. Again, this is the study guide. Please make sure you take notes. Best of luck on the test tomorrow.